Welcome everyone to our weekly Friday Transportation Seminar. I'm John Glebe. I'm an assistant professor in the School of Urban Studies and Planning. I sponsor this or help do, I don't know what I do. But anyway, besides emceeing, yes, I run this class along with Professor Kelly Clifton from Civil Engineering. And at other times of the year, Professors Jennifer Dill, Chris Monsier, and Miguel Figliozzi. Today, our guest speaker is Jimmy Kagan, who is the director of the Institute for Natural Resources here in Portland. He's going to talk about, on the thing it says road ecology, but here it's integrating transportation and environmental planning.
Right.
So before I turn it over to Mr. Kagan, what I would like to remind you all is that students in the class, there will be a roster sign-in sheet going around. And when it comes time to ask questions, including of our guests are welcome to ask questions, please try to use the microphones on the desk. And if the little red light comes on, it means it works. If it doesn't, then let me know and I'll come around with this. And with that, I will turn it over to our guest speaker.
Hi, everybody. Can you hear me okay? Oh, good. So the Institute for Natural Resources is Oregon University System Institute that has offices both in Portland at PSU and in Corvallis at OSU. And this particular project I'm going to describe is a project that's based on a research study with the transportation, the strategic, well, it's a TRB, basically, the Transportation Research Board. And it's a SHRP-2 project that basically was trying to address an issue related to sort of a common failure that people have in trying to get new transportation projects implemented, which is that they take forever. Basically, the first two slides here are slides that were put together by our SHRP program manager, who basically can go through this in about 15 minutes trying to describe what Congress wanted the Strategic Highway Research Program to do and why we need to do it. But I have way too many slides, so I'm going to go through this pretty quick. You can argue whether you really need this many new roads, but the fact is, to address the kind of growth that people are anticipating to deal with gridlock and to basically address the needs that society believes that they have in this regard, we need a whole lot more lanes than we have. And right now, the average highway time, if you're doing an EIS, is 13 years. So there's a lot of reasons why it takes so long to build a road from planning. We were trying to address one of them. And to outline the problem briefly, I'm going to describe this project that's going on. It's a study that's trying to use this method that I'm going to describe, trying to deal with a state highway, Highway 37, in California. This is, I don't know how many of you are familiar with San Francisco, but this is the very north end of the San Francisco Bay. And there's this road that basically runs to Novato from Vallejo, and it runs right along the north end of the bay. And this is a pretty good picture of what the road looks like. It's kind of a little bit of a problem, as you can see. The road's beginning to erode away in lots of areas. It's about 6 inches over sea level throughout much of it. And there's a bunch of erosions happening all over. In addition, with sea level rise, as anticipated, here's a map showing what sea level rise will likely do in the next 50 years, and this is just a 20-inch sea level rise. The road is right there at the very southern end, right along the edge of the bay. It'll be well underwater. In addition, all of these areas over that are currently being flooded are important marshlands, and those marshlands, a lot of them are already protected, and there's a series of endangered species in those marshlands, including salt marsh harvest mouse and a bunch of other ones. Anyway, this road is 2 lanes. It's narrow. It's constantly backed up. There's no place to turn around or pull off the road. When there's accidents, things get stopped forever. It's just the kind of thing that transportation people want to try to fix. Now, the problem with trying to fix this is that the whole road is through wetlands. It's all endangered species habitat. And traditionally what would happen is the highway department would work with their highway engineers and people in the local community and try to come up with some alternative routes. This is a plan for a corridor, and they would do a corridor plan, and they would look at a bunch of routes, come up with ones that seemed most feasible, and something like this, nothing is going to be particularly feasible, but they would come up with a couple of alternatives. And then after they were done with that, they would show it to the environmental regulators. I used to do that. It's not really, but I was an endangered species biologist, and we provided data. One of the things we do is provide data to the regulatory agencies and help come up with plans and strategies for endangered species. And what they would do is come up to us and say, what do you think about this route or this route or this route? And we wouldn't like any of them. We never did. And the problem really had to do with the fact that we were working off of different plans or different blueprints. And so the idea of this, which comes out of the Ecological program, and sadly I was supposed to have a box of Ecological books. Federal Highways offered to send it to me for me to bring to this thing, but unfortunately they refused to send them to post office boxes, and that's all PSU has. So they'll be here in a couple weeks. But what it is a way sort of to try to tie the work that the regulators have with the work that transportation people have. So we got this grant through the TRB. It included people from INR at OSU. It included people from CH2M Hill, from Parametrics, as well as NatureServe and some NatureServe members in Virginia and Michigan and Florida, Florida State University and Michigan State University. And basically, what we tried to do is develop this framework to basically look at methods to link transportation planning and conservation planning. The idea is if you put these things together, you might be able to do it at the same time. There's a series of steps. I'm going to focus on 3 of the 9 steps. I'm going to go through all of them pretty quickly, but 3 of the steps seem particularly relevant to Earth Day and to environmental stuff. The first one that I'm going to focus on is this development of a cumulative effects assessment and alternatives component, or a CEAA, which has something in it called a regional ecosystem framework. And hopefully by the end of this talk, those will all make perfect sense to you. The second part is trying to address one of the biggest issues for the transportation community, which is it possible, or what's the best way to get regulatory assurances? Can you develop new information, tie it into one of these regional ecosystem frameworks, and get pre-approvals for projects, or faster approvals for projects? And then the last piece is progressive mitigation, because mitigation is a large barrier. And I'll go into that in quite a bit of detail. And if I have time, I'll talk a little bit about ways to address mitigation if you use the idea of crediting for ecosystem services and measuring those ecosystem services. And again, why to do this? I sort of went through this already, but the real idea is to create a blueprint so that transportation planners can get access to natural resource information when they start. Not when they're done, not after they've designed something and spent years working on a bunch of alternatives, but before they start. The other thing is, if you plan simultaneously for transportation and for environmental conservation, you can potentially do both better. And the idea is if you get people together, you can agree on a set of goals and objectives, both for conservation or restoration or new development, new infrastructure, and come up with the answer. Basically, we tested this in a number of places, and it really does seem quite possible to get much better ecological outcomes and also better development. So this is the framework, and it's pretty ugly and it's pretty small right here, but we'll see if we can get through it. Basically, there's a set of 9 steps related to these three pieces that I was talking about. The steps 2 through 9 all sort of are part of the cumulative effects assessment and alternatives process, because basically they're all building this ecological and transportation and development framework. It's working with different people to make sure that the correct and proper information is in there. Everything is in there except for step 1, which is building partnerships. When we did this research study, they split it in half, and almost half of the work was spent on how to build partnerships. I'm not the kind of person who's going to be able to explain to you how to build partnerships. It's totally non-trivial, but you have to do it in order to make it work. It helps. I think people who are less geeky than I am do better. The second part deals with regulatory assurances, and this is the part that I worked on the most. And these are steps 3 through 9, and they basically highlight those pieces that you need, and I'll talk about those second. And then the last part has to do with these alternative mitigation mechanisms and ecosystem measurement. So those are the 9 steps. Obviously, I don't expect anybody to have memorized these or even, but we'll go through the ones at least that address those 3 issues. Steps 1, 2, and 8 we're pretty much going to just gloss over. So the first thing I really wanted to talk about, which is the most important and probably the most difficult part of it, is how do you basically create a ecological framework that people can live with, and how can you also make that framework work to allow you to evaluate all of the impacts that have happened before your proposed road development or any other kind of development, and also the needs of the ecosystem, plants, animals, habitats, everything. The idea is that you address everything. You need to be able to specifically address what your project is going to deal with. The framework was designed to be able to deal with very broad-scale projects, from corridors to state transportation plans down to specific projects. But by and large, you want to think about it. It works best anyway if you think about it in terms of an ecological framework, which involves addressing some geography that makes sense. Then you need to look at, within that geography that makes sense, that you can plan for, what resources are there, how are they going to be impacted in the short term and in the long term, how to address mitigation, and basically how can mitigation sort of deal with the short-term issues as well as long-term issues. And those last two mitigation pieces sort of are directly related. So the CEAA has a series of steps. The first step is develop a regional ecosystem framework. An REF, or a regional ecosystem framework, can be a number of things, but it's best to think about it as a blueprint, basically, a conservation blueprint. And if you can develop a conservation blueprint for a watershed, for the Willamette Valley, for a part of the state, for a MPO, then basically you can look at all of the resources that are there, and you can basically plan for the short term and the long term. When you develop an REF, you want to be able to build this database that has a list of the elements that are there, the important pieces of your biota, as well as your important pieces of your infrastructure. And for years, people have built conservation strategies and regional ecosystem frameworks by themselves. It's really easy for academics to do. We like to build models. We like to make plans. But if an academic gets together with another academic and builds a plan, it's pretty much not going to be of interest to anybody but other academics. So the idea here is to get people together, to get the transportation planners together, whether they're with the MPO or whether with the agency, and the people who can help answer these questions, as well as the regulatory agencies, nonprofits, and other people who care about conservation. You get them together, and you create this regional ecosystem framework. To deal with a regional ecosystem framework, there's a number of methods, but the first thing you have to do in order for anybody to take it remotely seriously is find out what other people have already done. The biggest downfall that we saw across the country is everybody wants to start over. Everybody thinks that they can come up with all the answers. And the fact is, even if you can, it doesn't do you any good, because all the people who've already done all this work are just going to blow you off. So you want to make sure that you look at everything. You don't have to accept everything. If there's a state wildlife action plan in your state and it's really terrible, then you can look at it and just kind of blow it off. But you have to have addressed it. You have to include it. You also have to look at other agencies' priorities, and you have to look at other sites that people have identified. There are often resources that don't fit in some kinds of analyses. So maybe, as was the case in 2/3 of the state, they didn't include plants in their conservation strategy. It sort of doesn't give you a ability to ignore endangered plants, because the fact is the U.S. Fish and Wildlife Service isn't going to ignore them. So when it comes to building your road, if you don't think about them, then you're not going to get anywhere. One of the trickiest parts, but also the most interesting parts, is basically trying to establish goals. What do you need? And the fact is, nobody can tell you what you need for any species or any habitat right now. There really isn't an answer. But you can come up with ranges, you can come up with things that make sense, and if you do this with a regulatory community, then people will generally agree with that. And you can always, one of the nice things about this framework that we came up with is that you have to build it so it's iterative. So you can create this thing, you figure out what you need, and just say, well, if things change, we can change it. And I'll go into some tools that we have that make it possible. You need to figure out both the primary threats and how those different species or habitats respond to those threats. And then you need to sort of develop at least a minimal set of scenarios that sort of define how things are likely to change in the future. And the fact is that last one is, I mean, if you read it and you think about it in detail, it's a little bit crazy. You can't possibly do it. So why would you even put something like that down? But the fact is, if you don't think about it, if you don't think about developing scenarios, how things are going to change, then you can't really plan. You can't really plan for transportation. You can't plan for infrastructure. You can't plan for nature. So here's part of Denver. And it's an example of a regional ecosystem framework and the scenarios, the cumulative impact analysis scenarios that were developed using a tool called Vista. It's a NatureServe came up with this tool, and they named it Vista, sadly, before Microsoft came out with theirs. And they're sort of stuck with it. But there's a series of other tools. Oregon State University has a planning tool as well called Envision. All of these tools tend to be things that you can download for free. Envision actually is an open source one. This one is ARC extension. So if you actually need to have access to ArcInfo, I believe at least 9. And you need to have familiarity with it in order to be able to use it. But what you wind up doing is combining, as I showed before, a whole suite of information on basically how things are developed. And here's the infrastructure. And you want to basically analyze a bunch of scenarios and look at different alternatives to meet both transportation and conservation goals. I said that a couple times. You do need a cumulative effects scenarios, basically something that shows how different types of development might impact both transportation and land use and also the conservation pieces. And you want to be able to sort of see what transportation effects will do under each scenario so that you could both identify the best transportation plan and also see how, if there's ways to both address conservation needs and transportation needs simultaneously. And so pretty quickly, in that same COG, in Denver COG, here's a map that shows important areas that are likely to be places of major growth. And the dark red areas are the places where there's important places that seem to intersect with transportation and land use scenarios. One of the things about these methods, and you can't possibly read this, but it's there to show you that the details have to be there. You have to list, these are the biological elements, and it uses some NatureServe jargon describing element occurrences, which are just populations of rare species. It includes habitats, which they define as ecological systems, floodplains, and they dealt in this particular one with issues like environmental justice and green infrastructure as well. But you can sort of see what's there, how it addressed those goals. You have to be able to establish these goals to make it work. For the ones that are highlighted in red over here, those are species. It includes the plain sharp-tailed grouse, species that has been wiped out of Oregon now. But so they set a set of goals, and you can basically look at a set of scenarios and just say, and what those little green dots, and that's really all you really need to be able to see are those dots right there. You know, is it meeting the goals and is it not? The tools also have to be able to show you where they're meeting the goals and where they're not. And this is a map down at the bottom that shows the one place that gives you the idea of where you have incompatibilities. The next thing you have to do, once you have this set of sort of alternatives and ideas of how those alternatives are going to impact your possible project, is you need to address actions. What ecological actions you're going to do. And in terms of address ecological actions, really, you only have two of them that are possible. What you can do is you can conserve or you can restore habitats. And when it comes to transportation and transportation planning, I mean, the transportation folks are not in the business of conservation in general. They are often in the business of restoration and mitigation because laws require that habitat loss, species lost, wetlands lost have to be replaced. And so understanding how restoration or mitigation is going to occur is really important. But the other thing you need to know, especially if you're developing a regional ecosystem framework, is are there places where conservation is going to do a lot of good? Because sometimes land conservation can help meet the conservation goals, make a species not endangered or less endangered so that you have the ability to do things that you need to do and potentially have some impacts. Conservation is something that you want to do with other partners, the service, NGOs. A lot of other people get together and are trying to conserve both wetlands and endangered species. Anyway, once you have a set of these, or you're working to establish these ecological actions, you can highlight the places where you are having the most conflict. And these red squares, which are really hard to see on this slide, over here, identified the priority areas in those green circles where there were the most conflicts with development. And basically you can say, well, all right, if we're able to work with an NGO or somebody to conserve that, how is that going to impact that? And basically, so you turn it green in your next scenario, and instantaneously, this particular site helps you meet almost all of your goals. So it's basically a tool that allows you to play with your conservation targets, how they're impacted on the landscape, how land use planning or transportation decisions are going to impact those. There's a number of different tools, and one of the ways you can actually address a regional ecosystem framework is without even using tools. The last step that I wanted to go over briefly is, and it's just another mention of the need for making sure that when you build one of these frameworks, when you build a regional ecosystem framework and you have these cumulative impact stuff and you build, there's a lot of data there and things change all the time. New lands are conserved, populations go away, new road projects are built. You need to make sure that the thing constantly is updated. In the past, people have, well, ODOT actually did this wonderful project that wound up saving them a bunch of money doing an analysis for the bridge, the billion-dollar set of bridge restorations that they had to do throughout the state. And they built a database that looked at species and habitats. And it actually enabled them to move forward with a set of programmatic decision-making so that they were allowed to much more rapidly influence projects. They basically had a set of agreements with NOAA Fisheries, who was one of the primary regulators, with EPA and the Corps, and they were able to move these projects forward. But one of the things that happened on that project, and it happens in a lot of other projects, is that people build this thing without the idea that it's going to have to be iterative, that they're going to have to maintain it over time. And so what happens is you build this thing, and then 4 or 5 years later, it's working fine, but it's out of date. There's a project out of Florida called I think it's EDMT, is that right? The Environmental Decision-Making, the Efficient Decision-Making Tool, something like that. I have, where sort of, it's the best example of that, where when they built it, it's exceedingly complex. It works exceptionally well, but they built it to only deal with the data that they knew about. And I'm going to talk about data now, but you have to make sure that whatever you build is iterative. What am I doing? I'm going too slow. So the next piece has to do with dealing with regulations. And in particular, what our research focused on are the primary bottlenecks, the Endangered Species Act and the Clean Water Act. And we hypothesized that basically, if you were able to improve the information that transportation planners had early in the decision-making process, they would be able to do a better job, both avoiding impacts and avoiding fights with regulators. Whether those two are related or not, I'm not going to go into. But the fact is, and my office, by the way, among other things, manages the endangered species information for the state of Oregon. So we are people who serve this data that doesn't actually work very well for what it's for. And I'll talk about that a little bit. So the idea is that you can improve this data to make it better at decision making. And the other primary bottleneck is mitigation. And it's because, by and large, mitigation isn't often successful for a number of reasons. And because of that, there's a lot of fuss about whether mitigation is sufficient to address the losses. So I'm going to quickly go through the ESA considerations. But by and large, Section 7 of the Endangered Species Act is consultation. Federal and state agencies have to consult with the Fish and Wildlife Service or NOAA Fisheries if there's potential impacts to endangered species. The way Section 7 works is that there's a set of data, and I'm going to show you some now, and both the transportation agencies and the regulators have access to this data. But unfortunately, it's not the greatest. It mostly, and it's interesting because it's as good a data as there is for what we were trying to put together at the time. Basically, it's information that's maintained by state natural heritage programs or conservation data centers, or in our case, the Biodiversity Information Center, that basically provides this data, and it's occurrences. It's known locations. An occurrence is a population, by and large, of a plant or an animal that's rare, threatened, or endangered. And the way we manage this data is in ARC with a set of lines, points, and polygons. And when we built this data set, it was for people who were doing project review. And the idea was a person had a project to review, and they were going to just look at one of these things and say, what are the odds of there being an endangered species there? But and so what we do is buffer these things by uncertainty. The bigger the circle it is, the less you know about it. So if you use it as an analysis tool, it's completely contradictory. You want to use the things you know the most about are the littlest, because you know exactly where the buffers are, you know exactly where they are. The reason why we did this is because at the time, people would just look at these individual maps and say, is there a project? But the fact is, the question people want to know isn't, is there an endangered species there? Because it's easy to find that out. They know that there isn't. The question that everybody wants to know is, might there be an endangered species there? Is it possible? And if it is possible, how possible? And so initially for Section 7, we developed these maps, and this is a very attractive one from New York, that the dots are the occurrences of the bog turtle, which is a listed species. And in the past, for Section 7, what they would do is they would overlay these things with counties and ecoregions, or in this case, subregions, to say, here's a map where these species might be. And they would give these to the service, and the service would use these things for Section 7 consultation. And if you have a road project running anywhere through all these areas, they would just say, well, you better check for the endangered species. The type of data that we're proposing that we want to develop across the country is the data on the right, which is a model. It's a predictive distribution model. And for years, we've been working on predictive distribution models. And there's a series of different types of ones. But it turns out that for rare species, inductive models, which basically a deductive model is a model in which somebody thinks that they know what's going on. So you tell this model that you have a species, let's say sharp-tailed grouse, and it really likes prairie between this elevation and this elevation. That's your model. You map it. You have this species in these prairies in its range between those elevations. That's a deductive model. What we started doing is using a set of things that are called inductive models, where basically what you do is you throw every bit of information you can possibly find at species, at the model. You tell it where it is, you tell it where it isn't, and it comes up with these maps. And this is a probability map of the bog turtle in New York. And what's nice about these things is that they're probabilities from basically 0 to 100. And you can make these things as fun as you want. And what's cool about them is that they really help both find new locations and tell you really, when you're in the range of the species, where you're not likely to impact it. And so for transportation planning, you can see how a map like this would be infinitely more useful, especially if the service liked it, which they happen to they do, because it also ties climate variables to it. And the Fish and Wildlife Service are quite worried about climate change and impacts. Here's one in Oregon that we did for an endangered plant, Astragalus epigatea, and I thought I had a picture of the damn thing. But anyway, here's the old element occurrences, and you can see the points and lines and polygons. This plant made the mistake of having most of its habitat in downtown Klamath Falls, which never works out for species. And so what's left is right on the edge of town, almost. I did a study of this thing, 20 years ago, and then I went back 10 years later, and almost every population was under Walmarts and Ford dealerships. So it's now federally listed, and you can't build any road projects on it anyway. But if you look at this, it's very difficult to figure out where the species might be. If you look at this, here's a model, again, from 0 to 100. There's a lot of places where it's pretty low probability, and there's a few places where it's high probability. And here's what you can do with the model, and this is what we did with the Fish and Wildlife Service. And the stuff in blue are the places where they want to use for mitigation and restoration. The places in green are what they want to do for Section 7. And it's quite a bit smaller than those other maps that you would. And you can refine these maps as you get more occurrences. But one of the cool things about them is that they do a very good job of predicting distributions where you have very few occurrences, which is something that happens for rare species. The other major barrier, and I'm going to have to go really fast now, is related to the Clean Water Act. And by and large, there's a bunch of parts of the Clean Water Act that cause problems. Water quality, runoff, there's a series of them. But by and large, Section 404, which is wetlands protection, provides the bulk of the barriers probably for transportation organizations across the country. And so dealing with wetlands was a focus of the research. And basically, this is a terrible slide because of how much stuff is on it. You never put this much on the slide. But the stuff in green has to do with part 1, which I'm going to blast through really fast, which is basically saying, if we only knew where wetlands were, we could avoid them better. It's a lot of words to say that. The stuff in purple is, if you knew where the best places to restore wetlands were, you could do a better job of getting wetland protected and mitigation approved. And so I'll go into both of those ideas pretty quickly. One of the things that's amazing to me is that in spite of investing hundreds of millions of dollars in the National Wetlands map put together by the Fish and Wildlife Service, this is what it looks like now. And a couple of years ago, Oregon was all white, as well as Colorado. So in spite of spending years of trying to map wetlands and making it available, the service hasn't done a very good job, largely because they don't get any money to do it, and because they want to do it exactly right. One of the things that we did in Oregon about I guess starting on 2006 now, was we noticed that we had some digital maps, and the ones in green were digital, and the ones in pink weren't. And we basically said, how fast and how quickly can we get all of those paper maps digitized? And we were able to do it for a couple $100,000. The Department of State Lands, who had been the state regulatory agency, had been wanting $1.5 million to do it for the last 5 years. And pretty much every state says the same thing. If you only give us $2 million, we'll let you know where all our wetlands are. But sadly, that adds up to $100 million, and nobody seems to have that right now. They actually never have had it. So the idea is that maybe the transportation community could work with other people, come up with some inexpensive ways, at least to make the available data better. We did this. We used, in Oregon, we got to use our prisoners who have a GIS lab. Very handy. They work cheap. We used students who also work cheap and don't mind doing GIS digitizing. And we were able to basically build that thing in a couple of years for not very much money. And now we have data, and we've been working to improve it. The problem with the National Wetlands Inventory data, the NWI, is it isn't perfect, and it doesn't actually work exactly like transportation agencies want. But it seems to me if you're doing transportation planning and you're trying to avoid wetlands, you might want to know where they are. The second part has to do with progressive mitigation, and I'm going to try to do this in about 6 minutes. I'm going to focus on the wetlands part of it, but to some extent, everything that I say about mitigation works for endangered species by and large, because you have to mitigate losses under ESA, although the wetlands one are the more common. And briefly, in Oregon, instead of in Oregon, when you're looking at road development, most of the roads are in and around the Willamette Valley because most of the people are in and around the Willamette Valley. And so instead of trying to build a regional ecosystem framework of our own, we noticed that there had been a whole lot of other studies that looked at ecosystems and species and habitats, including an ecoregional assessment that the Nature Conservancy did, including this PNW Ecosystem Research Consortium study that looked at alternative futures. I don't know how many of you are familiar with that, but it's an alternative study future thing where they developed a bunch of alternatives. They worked with land use planners, and they came up with ideas as to basically ways to allow for another 4 or 5 million people in the Willamette Valley over the next 50 years while still saving nature. The Department of Fish and Wildlife has a comprehensive strategy and so on. What we wound up doing here is actually what the Nature Conservancy wound up doing with a consortium of other people is creating what they called a synthesis map. And this is just an easy way to develop an REF. They basically overlaid all of those different things and said, where are places they had in common? And then from that, we basically said, all right, looking at those conservation priorities, where are there wetlands, both historic and existing wetlands? Where are the potential for wetland priority sites? And would this work? And it's a pretty straightforward thing. It's a really simplistic way to do it, but it worked. The regulators actually liked it okay. In Virginia, as part of this study that we were doing, they decided that they wanted to do it in a more sophisticated way. And what they did is they built this catalog of known and predicted wetlands. And the reason why they did it is because basically in 2008, the Virginia Heritage Program, which manages endangered species and is part of their Parks and Conservation or Recreation and Conservation Department, basically had a set of these maps. There were 122 sites that were their important sites. They wanted people to use it for wetlands restoration in and around them, and nobody ever did. And they were a little bit frustrated, so they thought, well, what is it going to take? So they did a pilot as part of our TRB study in this, however you say it, Pamunkey. I've only heard it said about 15 times, and I still can't say it. River watershed. And they divided this thing into 11 sub-watersheds, or if you're familiar with them, 5-digit, 10-digit EPA HUCs. And basically came up with this method that was a simple overlay. They took the parcels, which are the land ownership parcels in the county, and the sub-watersheds, and basically built the most complex wetland source thing that they could start. They started with the NWI, and you can see there are a lot of wetlands in this watershed. And then they added a bunch of other layers. They included the streams, which is the NHD, the National Hydrologic Data Set. They added a set of digital flood insurance places with the idea that if you could add flood probability to wetlands mitigation, you can get additional benefits. More people would want to help. And the same thing is true for soils. You want to know where wetland soils are and where the expansion is, and you also want to know where farmed wetlands are. Then they built a set of data layers for how to prioritize it. In this case, they had a group of people, including the Fish and Game Department, had built this national landscape assessment model, which basically said, from a landscape perspective, where are the biggest blocks of important habitat in the state? This was their biodiversity conservation places, the places that have the most rare species and the most rare remnant important habitats. So they added that. They added impaired waters with the idea that there might be benefits to do restoration in places where you're not meeting your 303D or your water quality requirements. And they added the existing wetlands banks or rivets. And basically they used those data, and healthy waters. They'd done an analysis of places that had the best waters as well. They put those things together. I forgot about farm wetlands too. Crap. Okay, and did a simple union overlay, calculated it. We're able to come up with priorities, and we're able to identify within each tract everything that was there. What were those things we're doing? The nice thing about it is that unlike the set of maps that we made in Oregon, everything is mapped. So every single wetland is there. It just tells you how good they are for everything, with the idea that the better they are, the more benefits you get out of doing restoring the habitat there, and the easier it's to convince people, if you're working there, if you're doing restoration in those important sites, then perhaps destroying a small wetland that isn't very important and protecting part of a large wetland that has a lot of benefits is going to be easier to come up with, easier to approve. And they also displayed it both by parcel and by both parcel and by each wetland type. The other group of people right now who are doing it, which is strangely enough coming out of Maryland, the Army Corps of Engineers and the EPA got together and built this thing called the Maryland Watershed Registry, which now runs, this is one watershed, but basically it's very similar, almost identical to what they're doing in Virginia. They basically, but instead of ranking everything, they built a set of GIS maps that show where the places are best for stormwater improvements, where the most important wetlands are, where the highest priority streams are, where the highest priority upland habitats are. They put them together and allow people to come up with ideas of where you want to restore habitats and do mitigation. And basically they developed a quick analysis which demonstrated that using this particular method, it saved a serious amount of money by reducing a whole lot of time in terms of getting regulatory approvals. The last thing I'm going to show you is sort of the last piece of it. The idea of integrating all of those different benefits for mitigation is a way to address basically this concept, which is ecosystem accounting. And the fact is, any bit of property that you have where you're looking at mitigation allows you to do a whole bunch of stuff. You can, if you do restoration and you create a wetland, you can both potentially store water, you could reduce flood risk, you can you can improve the water quality, You can protect species. There's a whole suite of things. And if you have measures for doing this, then you can get credit and you can get other people to come aboard in creating mitigation that's going to be really meaningful. I'm going to stop here. I just wanted to show this slide. The TRB has built this website called Transportation for Communities. The idea is that you can access information, planning information, and there's a set of decisions, a set of decisions that come along here, and this is just one row. There's actually probably 500-600 of them. I don't know if you're familiar with Transportation for Communities, but the website is transportationforcommunities.com. All of our research is here based on decision making and where those different decisions are impacted. So I'm going to stop there. Here's my contact information. I'm sorry I went so fast and had so much to cover. It was a 2-year research project with 15 people and $1.5 million. So I don't know. I could have left some of it out, I suppose. But thanks very much.
Hey, we have time for some questions. You can pick whoever you want to call on.
Okay. Well, so far, there's just one person, so it's pretty easy.
It strikes me that these maps could have a lot of cross-disciplinary use for other folks. Is there an idea to make them open source or to make them publicly available or available across different university or public organizations?
Yeah. As a matter of fact, I should have said that before, but one of the biggest, I have to go way back. One of the biggest problems with this is terrible. It's not going to let me do it. I mean, it actually just escaped. One of the biggest problems with the endangered species data is that it's sensitive. And so if you look at this data, it shows the exact location of every endangered species. So we can't actually make that available. But this data here doesn't show where the species are. It shows where they might be. And so that data actually can be posted online. Anybody can see it. And indeed, EPA gave us some money to post this data on endangered species on a tool for developers. Because if a land use developer is going to go out there and he's going to be choosing between which 3 parcels to buy to build a development, they might as well find out beforehand that there's going to be a wetland there, or there might be a wetland there might be endangered species there, or there's not. So yes, that's one of the main things about this. Everything that we have should be in the public domain. It should be available. Some of the tools aren't. Some of the tools aren't open source, but all of them are freely available. So it has to be that way or it won't work. Yeah? Hi.
I was curious about, is this working?
It's broadcast on.
Oh, okay.
I can hear you.
Sorry. I was curious about scale. Like, is this more appropriate at a larger scale because you're showing several examples that are at a watershed or a state scale? Or can it be applied at a very local scale? And then related to that, how does it, has it been used or does it work in an urban context? Because we're trying to do something sort of like this in thinking about long-range planning for the city of Portland and what the potential impacts are on watershed health. And so it's interesting to see the kind of data that you've used and how it relates to the data we've used. And I want to get a sense of how applicable your approach might be.
So in terms of the scale question, we tested it as the end of the project, and I didn't have time to show them, that we did some pilot studies in 3 different places on road projects, on specific road projects. One of them was a corridor project. One was just a highway project, Highway 20 actually, in Oregon. And so you can do it at any scale you want. The fact is, though, if you're building a regional ecosystem framework, it doesn't make a shred of sense to do it in a teeny area. The Portland metro area, the Portland-Vancouver area, is not a teeny area. It's big enough that it makes sense to plan on its own. Although the regional ecosystem framework that we built off of dealt with the whole Willamette Valley. So So it's tricky. Some places do cross lines, watershed lines, whatever. But most of the work that we've seen that's been successful has either been on a watershed level at a fifth field 10-digit HUC and I have never seen anybody come up with a plan for anything any smaller than that. But it should work on even projects. And the fact is, this data right here and some of those other data look pretty coarse, but this is a very fine scale data. Actually, this was built on a 4-meter pixel basis, which is pretty much as fine as you want to use for any kind of planning. You get finer than 4 meter, and you're going to blow up any computer you have.
Does it make a difference if it's an urban area or?
No.
Okay,
that example I showed was Denver.
Because sometimes
Last I heard
soils
that
and
was
things like
urban.
that, it's harder to get a sense of that.
The answers are never as good in urban areas, right? So you're not. The fact is, that if you're dealing with a larger landscape and you want restoration goals, if you have meaningful restoration and conservation goals, sometimes you just plain can't get them in an urban area. And it just means that you have to have more modest, more sensible goals, which the city of Portland always had. No, I mean, sensible goals is really the critical part of it. You have to be able to get goals that people are willing to accept. They can't be so demanding that you can't possibly meet them, and yet they can't be so loose as to cause you to basically continue environmental degradation. The other thing about this CEAA stuff is that it does build in cumulative impact. So you can keep it going over time. You build a database, you only have to build it once, and as things change, you can relatively simply update it. And again, all of this is open source software, and Envision is already developed for the whole Willamette Valley. I'm not sure about getting Vancouver in there.
I have one question from one of our web viewers.
Okay.
Okay. This person asks, in many cases, the wetland avoidance is far more expensive compared to the cost of purchases from wetland mitigation banks, except for consideration of the permitting issues. Is there any interest in creating new valuable wetland assets in a manner that reduces the regulatory transaction costs?
Yeah. How's that? So it's actually interesting. So when it comes to wetlands and mitigation, I'm doing another paper right now with some people on wetlands mitigation in general, the costs, and I have a couple extra slides showing sort of Florida as an example. Here's what Florida mitigation banks look like right now. And in the past, you can, by using mitigation banks, you can reduce transaction costs. It is cheaper and better in general if the mitigation banks are in the right place, and if the mitigation banks can achieve the conservation goals that people want. Sadly, there's been a series of studies, a whole lot of them out, that look at mitigation bank programs across the country. And by and large, most mitigation banks don't work. Now, ODOT's all work. But aside from Oregon ones, by and large, a lot of mitigation banks, and it's not that they don't meet the goals that they were set up for. It's that they don't work in an ecosystem context. They weren't designed to sort of build on other things. So they'll basically come up with what people said that they needed to do. The idea of coming up with a regressive mitigation approach is that mitigation can become an important part of conservation and restoration. That's the idea. If you do it in the right place, and you can protect lots of stuff, and then the conservation organizations, and then the regulatory agencies go, this really makes sense. We need to get on board. We need more of this mitigation. We need to take advantage of it to do conservation. So that's really what has to happen. We took a look in Florida because they're so far along using EDMT. And it turned out that Florida Heritage had developed through this Florida is one of the few places where pretty much any day now it's either going to be a natural area or it's going to be a strip mall. I mean, there's not going to be anything in between. There'll be wetlands and there's going to be strip malls, well, you know, and Disney World. But golf courses, those are the array of land covers for Florida. And so Floridians actually noticed this and came up with $1 billion, amazingly enough, for a conservative state, to save natural areas. And it occurred to them before they spend $1 billion, they might want to actually know where to spend it, which is pretty interesting. And so they spent some money doing an analysis of everything. And they paid Florida State University to come up with these analyses that they called their Florida Forever analysis. And they looked at a bunch of things, including groundwater recharge. They looked at rare species habitat conservation. They looked at functional wetlands. They looked at natural floodplain function. They looked at biodiversity. They looked at everything, offshore stuff. But the ones that related most to wetlands were those 4 and a couple others. And we just took a look at how well the existing wetland mitigation banks in Florida, how well the existing mitigation banks actually met those priority needs. And if you look at this thing, it's pretty terrible. I mean, look at natural floodplain function. I mean, it's 12% of all of their mitigation banks were any kind of priority for floodplain function. I mean, the fact is, same for surface water protection. Barely 1/3 of them provided meaningful surface water protection. Aquifer recharge. I mean, those are things that you'd think wetlands would do. So, and it's not that they did a terrible job. It's that they didn't use this information when they were prioritizing it, and they don't have the ability to prioritize it. People can't say you need to do mitigation in this place because it's better. It's not part of the way we work very well. And if we can do that, then we have the ability to do it. The way to do it, I think, is to value them higher. If you work in these places, you get them higher. Okay. You had a question?
Yeah. More of a comment.
Okay.
One of the biggest issues, and I think it's...
You want to introduce yourself quickly?
You want me to introduce myself?
Quickly, yes.
I'm Hal Gard. I'm the Chief Environmental Officer for the Department of Transportation. One of the biggest issues is regulatory. We do not get credit for conserving existing high-functioning habitats or wetlands.
That's right.
You only get credit for restoration or creation of new wetlands. And so in order to be able to invest in a bank and get long-term credit and have it be a high-functioning area, your investment doesn't pay off in the long run because you can't get those conservation credits. So there needs to be some fundamental regulatory fixes so that we can go through a planning process and an information data collecting process like Jimmy's outlined and actually get credit for long-term preservation of high priority areas. And that's a huge just disconnect that we have yet to figure out how to resolve.
Although the regulators, I mean, again, with the Maryland Registry, EPA's on board, those guys are on board, so it just hasn't happened across the country. I think it's, people are moving in that direction, but it's definitely something that needs to happen.
We're in love with banking.
Yeah, I know.
All that stuff off the critical path.
I know, everybody is. But the fact is, at some point, banks are going to all crash and burn if we don't figure out how to get them in the right place so that they're coming up with the kind of conservation that the regulatory agencies want. I ran out of time, didn't I?
It's okay. We're right on time.
Oh, good.
All right. Thank you very much, Jimmy.
You're welcome.
And for next week, our lecture will be on new energy vehicles demonstration in China. It will be, the speaker will be Zhenhong Yi, who is a postdoc here at Portland State University.
So people were giving me a hard time about jumping on Florida. So.